Hello and welcome to this 11th Algorithm Selection and Development lecture in this course, Master in Artificial Intelligence. So, in this lecture, we will talk about how to compare the performance of different models and architectures to identify the most effective ones, right? So, how do you think you can compare the performance of different models and architectures to identify the most effective one? Any thoughts? See, comparing the performance of different models in architecture is obviously essential for identifying the most effective one for a given task, the problem that you want to solve, and given the data. Now, so there is a systematic approach that we're going to outline for comparing the performance of different models and architectures as we go forward. So, take a look at that. So, what you need to do is to start by defining the evaluation metrics. So you define those evaluation metrics that reflect the specific goals and the requirements of the problem. For example, accuracy, precision, recall, F1 score for classification tasks, or mean squared error or R squared for the regression task. Then you choose the evaluation metrics that capture the aspect of the model performance that are most important for your application, right? Then what you do is you split the data into training, validation, and test sets. You the training set is used to train the models. The validation set is used to tune hyperparameters and select the best performing models. And the test set is used to evaluate the final performance of the selected model. Ensure that the data splits are representative of the overall data set and maintain the same distribution of classes or target variables across the sets. Then you need to train the multiple models and architectures using the same training procedures and hyperparameters. Experiment with various algorithms, architectures, hyperparameters, and pre-processing techniques to explore a diverse range of model configurations. Then you get into performing hyper parameter tuning using the validation set to optimize the performance of each model. As we mentioned earlier, use techniques such as grid search, random search, Bayesian optimization, and etc. to search for the parameter space efficiently. Then you evaluate models on the validation set on the using the predefined evaluation metrics, compare the performance of different models and architecture based on their validation set performance. Select the best performing model based on the evaluation performance on the validation set. Now, in doing that, consider not only the overall performance but also other factors such as computational efficiency, interpretability, and scalability. And once the best performing model is selected, evaluates its performance on the test set, which serves as an unbiased estimate of the model's generalization performance on work on the new data. Avoid using the test set for model selection or hyperparameter tuning to prevent overfitting of the test data. And finally, conduct sensitivity analysis to assess the robustness of the selected model to changes in the hyperparameters, data distribution, and pre-processing techniques. Evaluate the model's performance under different scenarios to gain insights into its strengths and limitations. So with that, we have completed the model selection and evaluation part in the artificial intelligence. We looked at how to select candidate machine learning algorithms of deep learning architectures based on their suitability as the first step. Then we trained and evaluated multiple models using appropriate evaluation metrics and validation techniques, and there we learned about cross-validation, hyperparameter tuning. And now we looked at, in this lecture, we compared the performance of different models and architectures to identify the most effective one. So having done that, what do we do next? So we will get into next major step of iterative development and optimization, where we will talk about How to iterate on the model development process by tuning hyperparameters, experimenting with different architectures, and incorporating domain knowledge. Then we will look at techniques like regularization, dropouts, batch normalization, and learning rate scheduling to improve model generalization and performance. And finally, monitor and analyze model training or validation metrics to diagnose issues and make adjustments accordingly. So it's going to be a longish uh, part of this course, and we will go forward with this. So thank you so much for watching this algorithm selection and development 11th lecture. I hope you're continuing to learn new things, continuing to enjoy, and I do look forward to see you again in the next lecture. Please feel free to message me if you have any questions. I'll be happy to answer your questions. And also download the PDF file to take a look at anything that is of interest to you, and you need to look at that.